Oh yeah, 15.5% change, part 2. How do I determine the percent error? Study tip, the amount of error is always positive. I don't know why that's a study tip. That's just something that's true, but all right, whatever. During quarantine, you estimate that the length of your hair is 16 feet. Wow. You know what? It might be time to just give yourself your own haircut, even though it could go drastically wrong. But the actual length, you were actually off. It's 21 feet, which is quite long. Find the percent error in your estimate. Okay, here's how percent error or amount of error is the same as the percent change that we were just talking about in the last example. Here's just a couple things need to be redefined. The original amount that we were using in the last problem, and this thing's getting super choppy, there we go. The original amount is the same as the actual amount. Oh my gosh, this is super choppy. Here, I'm turning it off, turning it back on. Is it going to work? No, okay, which is equal to the actual length, which in this case is equal to, and I'm gonna barely have room, 21 feet. Oh, I'm not gonna label, I'll try to label anyway. This is just for you, that's for you, okay? 21 feet. Now, what we were calling the new amount is actually your error. Your new amount, or not your error, it's your estimate. Your new amount is equal to your estimate. Which is equal to, oh my gosh, this thing is so bad. Equal to, you know what, I shouldn't complain. Life is okay. All is well. I need to read more Marcus Aurelius. Okay, everything else is the same. So now if we're going to find the amount of error, if we're going to find the error, Eric, that's my name. It's going to be equal to, same thing as before, we find the difference, and because it's always positive, you could just do the bigger number minus the smaller number. I know we were doing 16 minus 21 before, but we're just gonna do 21 minus 16. And we're gonna put that as a ratio over the original amount now is the actual length, which is 21. So you always put the real length down in the denominator, not your estimate. Then you get 21 minus 16 is 5 over 21. We have a fraction, and just like before, if we want to convert that into a percent, I already clicked on calculator. Right now I'm just waiting for the calculator to pop up. Still waiting. Still wait. There it is. Okay, so now I take 5 divided by 21. I get a decimal, 0.2380, blah, 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 blah. Now, there's a decimal, D2P, or multiply by 100. If the decimal goes over twice, you get 23.8. That's not a bad estimate, so we'll just, or it's just a rounding. So we're going to get approximately 23.8% error. All right. On big ideas, it may say round to the nearest whole percent, in which case we would say 24%. It may say round to the nearest tenth, which is what we did, 23.8. Okay, to find the percent error, first find the blank between the actual amount and your estimate, which is the difference between the actual, that was my cat meowing, between the actual amount and your estimate. Make it positive. Write the difference as a ratio over the new amount, or it says new amount, but new amount, of course, is the actual amount. Well, I should have said actual, huh? You know what? I'll do it. I'm going to do it just because. Whoever's staying with me, I'm really sorry that you're wasting this time watching me. Okay, the actual amount. And I can't even write actual on the line. Fail! Divide and convert into a percent. Oh, look at this. Nice, roomy. Oh, this is nice. All right, everybody, that's the end of 15.5. I miss you all. I hope you're doing well. I'm looking for 100% change at the beginning of next fall so I can actually be at school with you instead of teaching you through the interwebs. Have a really nice day. Mr. Plunkett signing out.